Good day everyone, my name is Shemer Bukay Serrano and I am the leader of this group. Together with my group members, we developed a project entitled Smart Inventory of Sales Management System using the Java programming language. The main objective of our project is to design and implement simple yet efficient system that manage product inventory and sales transactions. To achieve this, we utilize custom simply linked list to store and manage data for products and sales. Our goal is to create a user-friendly, reliable, and non-console-based applications capable and for performing essential operations such as adding, deleting, searching, and displaying product and sale information effectively. So the title of this project is Smart Inventory and Sales Management System. About the project is the Smart Inventory and Sales Management System is to console-based applications and design to organize and monitor product stocks and sales transactions. It allows user to manage two main types of data. So the product is containing the details such as a product ID, product name, price, and available quantity. Then sales is containing details such as sales ID and product ID, quantity sold, total price, the date and time and of the transactions. And then this is the system is implemented using the custom linked list. So product linked list is manage all product related operation such as adding, removing, searching and updating product quantities. And then sales linked list and records and display all sales transactions made within the system. And then the main features of system include adding new products, processing sales, which automatically decreases product quantity, removing products, and viewing details, list of both products and sales records. Overall, this project demonstrates the use of data structures. Linked list is a real-world inventory and sales management applications. So, while enhancing our understanding of object-oriented programming and algorithmic design in Java. So, classes created is before presenting the code. Here, the Java classes we developed for this project, product node.java, which is sale node.java, and product linked list.java, sales linked list.java, and then main.java. So, I proceed my code and then I explain it to how to create this. And the product node class is a fundamental part of our smart inventory and sales management system. It's represented a single product record within a linked list data structures, which is used to store and organize product information efficiently. Each object in this class acts as one node in the list, containing data about the specific product as well as link to the next and previous node in the sequence, making it part of doubly linked list. And then the class also includes the instructor that initialize all these fields when a new product is created. This ensures the Every new node in the starts with complete information such as ID, name, stocks, and price. So, furthermore, the class provides getter and setter methods for each data field. Then these methods allow controlled access and modifications of products details. For example, is you can use get stock and then to retrieve the current stock, or set stock to update its after sale. Similarly, set next, close and open parentheses, all the get stock, and then set stock, and then set next, and then set previous is we're going to ending is to type of close and open parentheses, and are used to link nodes together is the list, establish the connections between one product and another. So that's all, and another explaining about codes to creating our groups.
Dangal greetings everyone, I'm Archie Virgin P. Bartolome Jr. discussing SalesNode.java. This class is designed to represent a single sales transaction within a doubly linked list structure. Each node contains essential information including the sales ID, product name, quantity, and total amount, while also maintaining references to the previous and next nodes. This design allows efficient bidirectional traversal of sales data, enabling both forward and backward navigation through the list. By using getter and setter methods, the class ensures encapsulation and controlled access to its attributes, while the constructor guarantees that each node is initialized with all necessary data. The doubly linked list structure provides significant advantages for sales management, such as efficient insertion and deletion of records, dynamic linking of transactions, and the ability to implement features like sales history tracking, cumulative totals, and product-specific filtering. Overall, the Sales Node class offers a scalable and flexible framework for managing sales transactions, supporting real-time data processing and reporting in a sales or inventory system.
Hey everyone, I'm Van Albert Belges. Today we're diving into the sales linked list implementation and how our tester verifies it. Let's decode what's going on. First up, the class itself, sales linked list. This custom linked list handles sales records. What's objects or type sales or similar. What makes it interesting? Instead of a generic list, it's tailored for sales data operations. Here we see the fields, typically a head reference to the first node, maybe a size counter, and the inner node structure that holds sales, and the next pointer, good old classic linked list stuff. The construction set up and an empty list, head is equal to null, size is equal to 0. Now, add sales, or however it's named. This method creates a new node, set its sales field links it at the tail or maybe at the head of the list, and increment the size. We need to verify 3 things. After adding size is incremented, the new sales appears in the list in the right position, and no corruptive pointers. In example, the next reference chain correctly. Here's where the tester comes in. In sales linked list, it call method like add cell, remove cell, get cell at index, etc. It assert acceptation. Example, after adding two items, size equals to 2, get cell at 1, returns the second added cell. If any fail, the tester flag it. That's the verified part. Our code is not just running, it's being checked. Another critical method, remove cell or maybe delete at index. It must handle edge cases, empty list, remove head, remove tail, invalid index. The tester should cover those two. Also, the size should decrement the link chain, must bypass the remove node, and the head tail update must be correct. Alright, so what's the takeaway? Use a custom linked list when you need tailored behavior. Always maintain your invariance. Size matches actual node count. Link dot break, head tail pointer correct. And critically test every scenario, adding removing boundary cases. Thanks to our tester, we gain confidence that sales linked list behaves as expected.
Try to find a product list by unit ID that product notifies the result and ends without altering. Nevertheless, the function uses called a setter method to change its attributes if a product is successfully located. Due to a distinct product identification of the delete product, method is intended to eliminate a particular product that following the removal process to the action requires guarantees related to the list's foundational reliability is preserved. Description of functions. By looking for a specific ID to the procedure, initially tries to find a product that has to be deleted, and the procedure ends with notifies the user if no such product is discovered. Upon desired product is located is taken, or the list of the user will be informed. Other than informing the user, nothing is done if the product is not exist. In this product node contains attributes like name, stock, price, navigation, pointers, and etc. In this discussion, we are using the head and tail pointers to indicate the beginning and ending of assortment in the list of structured.
Greetings, sir. Justin Corsanes. Next, I'll explain this part of my code which focuses on managing inventory, specifically reducing stock, getting the total number of products, and displaying out-of-stock item. Let's start with the reduce stock method. This function takes in two parameters, the product ID and the quantity that needs to be reduced. Inside, it first searches for the product using the search product by ID method. If the product exists and its current stock is greater than or equal to the quantity of being requested, the code deducts that quantity from the stock using product that says set stock, close parenthesis, product that gets stock, close parenthesis, and equal, and quantity. After updating, it returns true to indicate the operation was successful. Otherwise, if the product doesn't exist or there's not enough stock, it returns false. So this method ensures that stock level never go below 0 and that only valid operations are allowed. Next, we have the get total products method. Here I created a variable named total and set it initially to 0. Then I use a while loop to traverse through the linked list of products starting from the head node. For every product, it adds the product stock to the total. Once all nodes are visited, it returns the total quantity of all product combined. This method gives us quick overview of the entire stock available in the system. And the display out of stock product method, this part checks and display all products that currently have zero or negative stock. It starts by printing the header out of stock products and then loops through the linked list. If a product stock is less than or equal to 0, it prints out the product name. A Boolean variable name has out of stock. Keeps track of whether any product met that condition. After looping, if no product was out of stock, it simply prints all products are in stock. This method helps monitor which item needs restocking immediately. And overall, these three methods work together to manage inventory efficiently, reduce stock, update stock levels, get total products, provide an overview of current inventory, and display out of stock products helps identify which item need replenishment.
Danga greetings, I am J.H. John C. Dugutuga. This code snippet defines two methods, display products and display products reverse, which are used to display the list of the products stored in a doubly linked list. The display products method performs a forward traversal starting from the head of the list. It first checks if the list is empty by verifying if the head is null. If it is, it prints a message saying there are no products in the inventory. Otherwise, it prints the details of each product such as ID, name, stock, and price by moving through each node using the getNext method until the end of the list it reswitch. On the other hand, the display products reverse method performs a backward traversal starting from the tail of the list. It also checks if the list is empty by verifying if the tail is null, and if is not, it displays the same product details but in reverse order, moving from one node to the previous using the getPrevious method. Together, these methods allow the users to view the inventory both from the first to the last and vice versa.
Dangal greetings, my name is Sean Patrick Camuli and I'll be discussing sales linked list. The sales linked list class is used to record and manage all sales transactions in a linked list structure, and it connects to the product linked list class to get product information and automatically reduce the stock whenever a sale is made. And the class has three main variables. It is head and tail, which is represent the first and last sales in the list, and next sale ID, which automatically increases for every new sale along with total sales, which keeps the track the overall sales amount. When the record sale method is called, it first searches for the product by its ID. If the product is not found, it prints product not found and stops the process. If the product exists, it then checks if there is enough stock by trying to reduce it through the reduce stock method. If there isn't enough stock, it prints not enough stock and stops. If there's sufficient stock, the method calculates the total sale price by multiplying the product's price with the quantity. Then creates a new sales node that stores the sale information if this is the first sale. It becomes the both head and tail of the list. Otherwise, it gets added to the end of the link.
generate summary method which create reports and analytics using only linked list. First, it prints the title reports and analytics. Then it shows the total number of product in stock by calling the get total products method from the product linked list class. Next, it displays the total sales revenue which is stored in the valuable total sales. After that, the program identifies the most sold product. It checks if the sale list is empty. If not, it uses two loops to go through the linked list. The outer loop picks a product and the inner loop counts how many times that product appears in the sales record. It then compares the quantities to find which product has the highest sales. Finally, it prints the most sold product name and total quantity sold. If no product is found, it displays NA. The last part calls method display of out of stock product to show all the products have zero stock left. In short, this method summarizes all important sales information including total products, total sales, top selling product, and out of stock items using linked list operation. Thank you, sir.
Greetings, my name is Kirby Dembe Ondastro. The main Java file is the core of the Smart Inventory and Sales Management System. Upon the execution of the program, the main method is invoked which instantiates two linked list objects, product linked list products and sale linked list sales, used for the storage of product and sale data. The powered data takes up the user input and some default products like Pasit Canton, Tinapay, soft drinks are added through add product method which creates a new product node and connects it to the list. The application then enters a loop where a menu of option is displayed. The user choice is passed to a switch statement which then executes the corresponding action. Option 1, add product. As per the user information equals add product, afterward is shown by the list calling display product and display product reverse. Option 2, update product. Find the product by ID with the help of search product by ID, then allow the user to change the product name, stock, or price through respective setter methods like set name, set stock, set price. Option 3, delete products. Calls the delete products to erase a product node and replaces the display list accordingly.
Greetings, I am Andre Vincent Barala and I will continue discussing the main Java program. In this part of code, we handle several menu options that allow the user to interact with the system, such as viewing products, searching, recording sales, and generating reports. In case 4, view products, both direction. When the user chooses option 4, the program displays all the products stored in the system. First, it will show them in normal order using the display product method. Then it shows them again in the reverse order using the display product reverse method. This will demonstrate that the system can traverse the product list both forward and backward, which is common when using doubly linked list. Case number 5. Case number 5, search product by ID or name. Option 5. The user allow to search for a product. The program first asks whether the user wants to search by product ID or by product name. Depending on their choice, it reads the user input using the buffered reader. If the user chooses one, the system asks for the product ID and search using the method. Search by group, search product by ID. If the user chooses number 2, it asks for the product name and search using search product by name. After search, the program checks if the product was found. And if the product exists, its full details including ID, name, stock, and price are displayed. Otherwise, the program tells the user that the product was not found. The case number 6. Case number 6, record sale. For option number 6, the user can record a sale transaction. The program asks for the product ID and the quantity sold. It then calls the record sales method from the sales object, which processes the sale update, the stock of the product, and stores the transaction record. Case 7, view sales. Option 7 lets the user view all the record sales. It calls all the display sales, which show the details of each sales, such as product sold, quantity, total amount, and date or time of the transaction. Case number 8, report and analysis. Option number 8, it generates the summary report. These features analyze the sales data and may include total sales, best-selling products, or revenue reports. It calls the generate summary method, which provide an overview of how the business or system is performing. And last, case number 0, exit. Finally, option 0, exit the program. The program prints simple message exiting program before stopping the loop.
Here's the sample output. Let's run the main.java. Here, there's a dummy data, Pancit Canton, Tinapay, and soft drinks. Then first we add choice 1, add product. Then enter a product name, which is itlog. Then enter the quantity of stock, 100. And then enter price, which is 8 pesos. And enter, you will see the product list. The itlog is added in ID 4, which are the stock 100 and price is 8. Let's update product, choice 2. Then enter the product ID to update. Let's update the ID number 1, which is the Pancit Canton. Then select what do you want to update, the name, stock, or price. Now proceed to the name. Let's change the name of Pancit Canton into, let's say, noodles. We see the ID 1 changed to name noodles. And then update again, then select the stock. Now then the stock is 20, then update it to 100. And that's it. The ID 1 noodles, change the stock to 100. Then let's change the price, which is 30 in first. Then update the number 1 again, which is the noodles. Then enter the new price, which is 30, change it to 10 pesos. And now the noodles update into stock 100 and the price is 10 pesos. Now let's delete a product. Then select enter product to ID. Let's delete number 2. And let's you see the product list is missing 2 because we delete it. Then review products. It's automatically view all products with forward traversal and backward traversal. And in search product, we used to search the product using ID or name. Then first we select the ID, search product by ID, then enter the product ID do you want to search. We search for number 3, and the 3 shows and show the details, name, soft drinks, stock 50, price 7. Then let's try again the search product and try the name. We search for the soft, let's say itlog. And the product found because the itlog is in the queue, in the list, so that the product itlog is shown. Then let's search product without in the list, and enter product ID number 2. Number 2 product is not found because the number 2 product is not in the product list because we delete it earlier. Then let's try the name to search. Let's say Pancit Canton, we deleted it earlier. Then now, the pancit canton product not found. Oh. Because we deleted it earlier, as you see in the product list, there's no pancit canton. Next is the record sale. If you want to add orders, like when the customer buy, let's buy a product ID 1, which is noodles. Then they want to buy 20 pieces, and then the sale record for noodles times 20, and it added to the record in a view sales. When we view the sales, it shows the product that we show. We add, then show it's the product noodles quantity, and 20 times 10 pesos the product noodles, and 20 times 10 is equal to 200 total. And the view reports, we can see all the report analytics, which is the total product, including all the product, which is the total of all, and the total sales revenue, which is the total sales that ordered. Then the most sold product, which is the noodles. We add sale earlier, which is 20 noodles. That's why the most sold product is noodles. And out of stock products is all products are in stock. It shows when no one is out of stock. Then we exit.